Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about this FIR ideal high pass filter. So last class we have discussed and computed up to the filter coefficients. Now we are going to take the individual values. So last class we have drawn this plot and then we have finded this HD of n. Also we have finded the final expression. Now we are going to find the individual samples. So first thing I am going to find a h of 0. So we can use two methods. One is before integrating expression, or we can use limit methods. So if the reason is 1 divided by we have an n pi. So once if you substitute 0 here, 1 divided by 0 becomes infinity. That's the problem. So we can use a limit method, or we can use that before integrating expression. So when we seeing a low pass filter, we have seen the both methods. So now we are going to see this limit method. Look at this h of 0, limit n tends to 0, sin n pi divided by n pi. So minus sin n tends to 0, sin n pi by 4 divided by n pi. So we have these formulas. So limit theta tends to 0, sin theta divided by theta will be equal to 1. Similarly, limit tends to theta equal to 0, sin n theta divided by theta will be equal to n. I am going to use these two formula for this. If you substitute it, I get this 1 minus pi by 4. So we can subtract this value. Now we can find for an n equal to 1. So n equal to 1, we take this h of n, that will be same as h of minus 1 also. We have the formula sin n pi minus sin n pi by 4. So we can use the same thing. So h of 1 equal to sin pi minus sin pi by 4 whole divided by pi. That will be equal to minus 0.225. Same thing we can do it for a h of 2. So h of 2 equal to h of minus 2 equal to sin 2 pi minus sin pi by 2 divided by 2 pi. So this is minus 0.159. Similarly, we can compute it for h of 3, 4, 5. So this is the value for h of 3, 4, 5. Once if we compute it, we can go for an filter transfer function. So actual this we computed is not a realizable. So we need to make this as a realizable also. So first we write the transfer function. So h of z equal to h of 0 plus summation of n equal to 1 to n minus 1 by 2 h of n into z power n plus z power minus n. So we know the h of 0 and then we know the h of 1, 2, 3, 4, 5 value also. Just substitute and expand it. So again we need to multiply with these values. So this is h of 0, this is h of 1 into z power 1 plus z power minus 1. This is h of 2 value into z power 2 plus z power minus 2. And this is h of 3 value and then into z power 3 plus z power minus 3. h of 4 value is 0. Look at this. So that's why I am skipping this. Take this h of 5. So this is h of 5 value 0.045 into z power 5 plus z power minus 5. So this filter is not realizable. So we need to multiply with the z power minus 5. That is z power minus n minus 1 by 2. So h dash of z equal to z power minus 5 into h of z. So we need to multiply this z power minus 5 with this all this function. So just expand it. So look at this. If you multiply with z power minus 5, you get 0.75 into z power 5. So this value we need to multiply with z power minus 5 also with z power 1. This is z power minus 1. So if we multiply it z power minus 5 into z, it becomes z power minus 4. Look at this coefficient z power minus 4. We have the minus 0.225 value. Similarly, if we multiply with this z power minus 5 with the minus z power minus 1, it becomes z power minus 6. Look at this coefficient z power minus 6. The same coefficient minus 0.225. Similarly, we multiply all the things. That is, the coefficient should be multiplied with inside that z value, also this outside z value. So this is the final expression for this. Now we need to write the h of 0, 1, 2, 3, 4 actual coefficient whatever we are getting, that corresponding coefficient. This is h of 0, this is h of 2, this is h of 3, h of 4, h of 5, h of 6, h of 7, h of 8 and h of 10. That corresponding value will be taken for the h of values. Look at this, I am writing the h of value. Now we can go for a h bar of e power gamma, we can expand it. So from n equal to 0 to n minus 1, a of n into cos omega n. So we know the formula for this. A of 0 is h of n minus 1 by 2 and then a of n equal to 2 into h of n minus 1 by 2 minus n. Now substitute this value, we can find a of 1, 2, 3, 4, 5. Once if we find it, we write the expression for that. So once if we substitute this value, the expression becomes 0.75 minus 0.45 into cos omega, minus 0.312 into cos 2 omega, minus 0.15 into cos 3 omega, cos 4 omega is 0, 0.09 into cos 5 omega. So we can expand this. So we have to substitute from 0 to 180 degree. We can increment with the 0 10 degree or 15 degree. Here I am incrementing with the 10 degrees. So we need to take this value of omega from 0 to 180 and we need to find a h of e power j omega. So this expression will be used. So inside that we need to substitute omega value. So for a 0 we need to substitute omega as 0. 10 we need to substitute omega as 10. Similarly we need to substitute up to 180 degree. So this value only put it here. After that we need to take a find the dB. So for that we need to take a modulus for this h bar of e power j omega. After that we need to take a logarithm and we need to multiply it. So 20 into logarithm of h bar of e power j omega, that is modulus of h bar of e power j omega, that will be plotted here. Look at this. This is the value for this. Now after this we need to plot this omega versus h bar of e power j omega in terms of dB. So this is the frequency response. So we have some small oscillations. After that we getting a actual high pass filter response. Thank you.